So in this video we're going to look at, we call them simple exponential functions. They're not necessarily simple, they take some work, but they're just a very special type of exponential equation. So with this, it takes a very specific setup. Later in our course, we're going to have a whole week of solving exponential equations where it won't be these kind of special cases coming through. So we'll see these again. It's just I want us to recognize something with these specific cases and make it so that we can solve them. But right now, as I mentioned in our kind of introduction video, when we try to solve for exponents, we get stuck because we don't have logarithms yet, which is what's coming up next. So until then, what we need are these kind of special cases. So again, solving equations, it's all about finding a value for x that balances the equation. It's the idea of what can we plug in here that balances with the other side of the equation. Now what makes this really special is that these have the same base. And that's what we're going to look for in these cases, is kind of the same base. Because if it's the same base, then they matter, but it makes it a little easier because then all we can focus on are the exponents. And then I want to balance those exponents then. So it's not really about balancing the whole thing. If the bases are the same, then it's about balancing the exponents. So with this, it would be to make this equation work, I would need that exponent of x to be equal to that exponent of -6. Which makes sense if we plug it in. If we plug in -6 for x, then we have 5 to the -6th, 5 to the -6th. We don't even need to calculate it with that. We can see that it's balanced. So that's the concept we're going to use here, is that if we can create the same base of the exponents, then really it's just about getting the exponents to equal each other. So let's look at this case here. We have 4 to the 2x minus 5, and then I have 1 over 16. So what I'm going to do is I'm going to try to match the base there. So I'm going to keep the left-hand side of the equation the same, but what I could see is from the 1 over 16, I can express that another way with 4 as a base. Now, this turned into a fraction, so that tells me that the exponent should be negative. And then it's 16, which comes from 4 squared. So what I just did there is I re-expressed 1 over 16 as a base and exponent with 4 to the -2. And how I think of that is just like how I said it out loud. Since I see a fraction, I think of the negative. And then once you take care of the negative and how that creates the fraction, like it moves it into the denominator, then you can see that exponent of 2. Or if you want to write it out, it's like that 1 over 16 comes from 1 over 4 squared, which is the same thing as 4 to the -2. So it's that we would move 4 squared into the denominator and then simplify to the 16. Alright, so solving the equation, now that I have the same bases, it's that I need the exponents to be equal to each other. So what I can do is then change this equation so that it's just about the exponents. That whole exponent of 2x minus 5 has to equal that -2. And then we can solve. So I'd add 5 to both sides, divide by 2, and I see I get this x equals 3/2. And then we could check our answer. We go to a calculator. So I would have 4 to the power of, and I'll need some parentheses here, so 2 times 3/2, or I could simplify that to a 3. But let's type it all in. 2 times 3/2 minus 5. And if we look at the fraction version of that, there's our 1 over 16. So we found the value for x that would balance both the sides of the equation. Just came down to getting those exponents to equal each other. Alright, let's try this again. So what I can see is this base of 5 over here. I have this 125, which I know is the same thing as 5 cubed. So what I'm going to do is change things around a little bit And where I have 125, I'm going to change that to a 5 cubed. And then I still have this exponent of 2x. So I have this 5 to the x squared plus 8 equals, and then we multiply the exponents. That's our power to a power rule. So in this video, we're going to get some exponent rules practice again, like we reviewed at the beginning of the term. So 3 times 2x is 6x. So this is the same thing as 5 to the power of 6x. All right, so now what we have is base 5, but with these different exponents, and we want those exponents to be equal to each other. So what we can do is take that exponent of x squared plus 8, and we want to see where does that equal 6x. This is quadratic, so I'm going to subtract 6x from both sides of the equation. And I'm going to factor. There should be an x minus 2 and an x minus 4. So x minus 2 equals 0, and x minus 4 equals 0. So x can be 2, or x can be 4. And let's check those solutions. So I have 5 to the power of, let's see, x squared, let's make that 2 squared, plus 8 gives us that big old number. And I'm going to go ahead and enter that. And that should equal 125 to the power of 2 times 2. And we get the same numbers there, which is perfect. I'm going to do the same thing, but plugging in 4. I'm just going to go ahead and edit these. So 4 squared, we get a big number. And then 2 times 4, and we get the same very large number. So we can check our answers in there, plug in our exponents. All right, let's look at a few more of these. So let's go up here to D. So 2 to the 2x minus 1, I'll keep that in that form. But then 4, I'll express as 2 squared, so that now we have the same base. Now all we want is to have that exponent 2x minus 1 equal that exponent of 2. So 2x minus 1 equals 2. Add 1 to both sides. Divide by 2. And we'll get x equals 3 halves. And we can do kind of a quick check. If we plug in 3 halves, that'll be a 3 minus 1, which is 2. So 2 squared is 4. Perfect. All right, this next one, we'll have 2 to the 3x minus 1, and then 32 is the same thing as 2 to the 5th power. So that 3x minus 1 needs to equal 5. I'm going to add 1 to both sides, divide by 3, so x is 2. If I plug in 2 there, 3 times 2 is 6, minus 1 is 5, and 2 to the 5th is the same thing as 32. All right, those were kind of nice ones. Now let's end with a tricky one. This will get some good exponents practice with it. So basically, I'm going to try and get everything into base 3. So 9 is the same thing as 3 squared, and then we have that exponent of 2x, times 27 is the same thing as 3 cubed, and then we have that exponent of x squared, and we want that to equal 3 to the power of negative 1. Now my power to a power rule, so 2 times 2x is 4x. So this is really 3 to the power of 4x times 3 times x squared. So that's the same thing as 3 to the power of 3x squared. And that equals 3 to the negative 1. All right, an exponent rule that we have, for a little review, if you're multiplying values that have the same base, we add the exponents together. So what I can do is combine these to a base of 3, and in the exponent I'll have that 4x plus 3x squared. That equals 3 to the negative 1. So what we want to solve here is that exponent of 4x plus 3x squared should equal negative 1. I'm just gonna, this will be quadratic, So I'm going to change it to standard form and add 1 to both sides. And factoring this, she get 3x plus 1 and x plus 1. And then solving, 3x plus 1 equals 0, so 3x equals negative 1, so x is a negative 1/3. And x plus 1 equals 0, subtract 1 from both sides, x equals negative 1. And let's just check those answers. So I'm going to go back to the original form of the question and do 9 to the power of, and in parentheses 2 times, and I'll go ahead and plug in the negative 1/3, and then times 27 to the power of negative 1/3 squared. And what you can see there is we're getting a 1/3, which is the same thing as 3 to the negative 1. So x equals negative 1/3 works. And then let's change this to a negative 1. Oops. There. And we get our 1/3 again. So we can check our solutions and make sure that they work out. So again, special way of solving exponential equations, but it takes these very specific cases where you can get the same bases on both sides of the equation. So then you can kind of eliminate the exponential part and just focus on where do those exponents equal each other.